Well, good afternoon, everybody, and welcome to NASA's Johnson Space Center. I'm Dan Hewitt, and we are, of course, here to talk about the one-year mission. Scott's home after 340 days in space. He was doing a lot of really important science on board, which is continuing now that he's back on the ground, so we're here to talk a little bit more about that. I'm joined today by Dr. Julie Robinson, the Chief ISS Program Scientist. I'm also joined by Dr. John Charles, the Chief Scientist from NASA's Human Research Program. And then, of course, Mark Kelly there on the end. You might recognize him. He's Scott's twin brother and was a participant in this twin study that took place down here on the ground. And we have a lot of folks here in the room and a lot on the phone, so I won't waste too much time. But just to give our participants a quick moment to start off, Julie, I'll start with you. Now, Scott was up there for 340 days. Obviously, human research was a big part, but there was a lot of research taking place on board the station. Give us just a quick idea of just the breadth of studies that he was involved in during the year in space.
Yeah, there were over 450 investigations that were done on ISS while Scott was there, and the breadth covers almost the entire breadth of science. There were life sciences investigations with stem cells and worms and other kinds of organisms, helping us to understand the mechanisms of how life responds to space. There were physical sciences investigations with fuels burning in a controlled environment, fluids like colloids being tested for their self-assembly processes. And then there were technology demonstrations where we were evaluating future technologies for life support, autonomous rendezvous and docking. There were education activities that accompanied some of these, like we had these spheres on ISS floating around. They were testing autonomous rendezvous and docking and structure of fuel tanks, but students also got the opportunity to program those as part of the Zero Robotics competition. So there were great things that were added to some of our investigations to make them important to students on Earth. And then outside the space station, there are really important instruments attached. The alpha magnetic spectrometer is measuring the nature of dark matter and dark energy by looking at galactic cosmic rays. And the instruments like RapidScat and CATS are looking at the Earth. So RapidScat was really key data for modeling the intensification of hurricanes throughout the entire last season, all based on ISS. Commercial companies are doing a lot of research on ISS. There were both CubeSats that were deployed for different commercial companies, and also a lot of experiments done inside the ISS for research and development efforts. So this huge amount of research was going on. Of course, people are going to want to know all about the experiments with the twin study and the experiments on human physiology, but it's just good to have that context of what an amazing research laboratory the ISS is today.
Okay, and John Charles, again, our Chief Scientist for the Human Research Program. Now, at the core of the year in space, a lot of it was that human research. What were some of the different studies you guys were doing, the different bodily systems that you were looking at during Scott's year in space?
Julie mentioned 450 investigations on this mission. Only 18 were human research program missions, but we seem to be few in number, but take lots of crew time and lots of effort, and of course, fairly highly visible. There are 18, including the twins study, which was one of our investigations, where Scott was also doing 2 investigations from the Russians and 2 from the Japanese as part of our truly multinational collaborative effort. And the studies were typical of space station kinds of studies. Some of them were carryovers from his previous 6-month flight, so we would have some basis of comparison between his time in space for 6 months and his time in space for 1 year. And some were new for this mission, and they are continuing on other missions. The 2 flagship investigations were the in-flight fluid shift study, which was a truly international investigation. It required moving a lot of American monitoring hardware into the Russian segment and using the Russian medical system, including a device that relocates body fluids as a way to investigate the changes in fluid distribution in the body and see how they might or might not impact the changes in visual acuity that occur in spaceflight. And another one is the post-landing field test, which was done immediately after landing when both Scott and Mikhail were escorted from the Soyuz into the medical tent. And in the medical tent, they were both asked to do a series of activities that mimic those an astronaut newly landed on Mars might be asked to do: standing up, recovering from a fall, walking, bending, lifting, things like that, as well as some additional vestibular and sensory motor tests. So those are the flagship investigations, but otherwise we did other investigations on cognitive function in flight to be followed up post-flight with cognitive testing that involves actually doing tasks while the brains are being scanned inside of an MRI. A lot of metabolic studies, lots of blood draws. Over almost a half a liter of blood was drawn from Scott during his time in flight, in a series of blood draws periodically throughout the flight, and other bodily fluids were collected as well. And generally just assessing his ongoing capabilities as a functioning crew member on the International Space Station as a model for people moving in beyond low Earth orbit on exploration missions beyond low Earth orbit off, say, to Mars. So essentially spanned the gamut of physiological and psychological systems, and now we're in the phase of collecting the data and starting to analyze the data and seeing what we really learned from this mission.
All right. And then Mark Kelly, former NASA astronaut, space shuttle commander. You were no stranger to doing science and other things in space, but you took a different role for the last year. What was the year in space like for you down here on the ground?
You know, my first flight, we had some rodents on board where they were the subject. And now on this flight, for this last year, I've been the subject, at least the control on the ground. So a little bit different role than actually flying the spacecraft, but it's you know, it's been an interesting experience. I've made probably maybe 4 trips or so here to the Johnson Space Center, where I'll spend some time in a laboratory hooked up to all kinds of equipment. Might be an ultrasound machine or this lower body negative pressure garment, given a lot of blood and urine and other samples. Yesterday I was over doing a stand-up MRI. I have a 2.5-hour MRI tomorrow. If there's anybody in here that doesn't like being in an MRI machine, just think of me sitting there for 2.5 hours or laying there tomorrow as I do this. But it's been a good experience working with the researchers here at NASA, some really smart and top-notch people who are trying to collect data, not necessarily for themselves, but data that they're going to be sharing with the 10 research universities around the world, if you count the one university in Europe. So it's been a good experience. At a number of times, NASA came to me to take blood, whether I was in Arizona or in some other city in the country. So it's been a positive experience, but what I'm really looking forward to is seeing the results of all this research. Mm-hmm. And that's going to take a little bit of time. I get the impression that some of these studies are going to start to have, you know, some initial findings, but others, I imagine, would take, you know, maybe up to 6 months or a year before they, you know, start writing the research papers and making conclusions on this longer trip into space.
All right. Well, now we want to start taking questions from everybody gathered here, everybody on the phone, and also on social media. A reminder for those on the phone, if you have a question, you need to press *1 to get into our queue, and you can press *2 to withdraw. And if you're following on social media, use the hashtag #AskNASA. So for those in the room, just raise your hand, state your name, affiliation, and who's it for. Go ahead.
Hi, Tom Costello with NBC News. Dr. Charles, you know, Mark just mentioned it is early. You still have to disseminate the raw data to the universities. You look for some sort of result. Is there anything early? Are there any early interesting findings that you've already come up with?
No.
Nothing at all.
Not that I can tell you about. But the point is, the data analysis is only now beginning in earnest. We have, especially for the twin study, the metabolic data that are acquired are going to be batch analyzed, which means that all the samples, or most of the samples, will be analyzed by the same technician and the same hardware at the same time in the same place. So any differences we see are not related to variations between the technician or the location or the time or how long they were in the freezer and so forth. And don't forget, some of those samples are still on the station right now. They're not coming back until May on SpaceX, the next landing, which carries a freezer. The Soyuz doesn't have a freezer on board, so it can't bring back the frozen samples. So literally, no, not yet.
Scott did mention something about his vision changing.
Yes, he did.
His vision changed after his first flight. He's made that, you know, clear, which is a, you know, not an uncommon thing to happen for long duration crew members. So it's happened in the past. It happened on his last flight. And, you know, I think he's just starting to get a sense of the impact on his vision from this year-long mission. I don't know if he's done a vision test yet, but just anecdotally, I think there was an observation that he had there.
Okay.
I'm Mark Carreau from Aviation Week and Space Technology. Before the launch, there was talk of doing one of these long-term flights, so-called one-year flights. A couple things have changed since then. One, you legislatively have more time on the space station in orbit, and two, you begin to talk about in-space habitat that also might be a setting for this kind of research. So I wonder, are there going to be more? And if there are, will it be soon? And where?
Yeah, well, of course, scientifically, the question is very clear, and John and his colleagues have done the analysis, and we really would like to see 10 or 12 crew members with long-duration data in order to be confident that sometime when we go around the table and health and medical says they're go for Mars, that we know what all the risks are and we've alleviated them all. So at its core, scientifically, we need more subjects. Now, there are a lot of partnership issues that we have to work out in deciding who those subjects would be, when those subjects would fly, and we're still working on that with our partners. And one thing that's really important is having this first set of data back as we get some of the early results over the next year to 2 years, and as we work with our Russian colleagues and the data, because it's not just the data on Scott, it's also the data on Misha, and as that data gets together, we're going to start seeing if it is absolutely urgent that we get some more crew members right away, or is it something we could backload maybe at the end of ISS? So we still don't have that information either.
Would you have women as subjects, I presume so, but I just wanted to make sure that you want to have a representative.
Oh, absolutely. NASA never distinguishes between men and women in anything regarding employment. It's true in my career, and it's true for astronauts as well.
There might be other diversity factors, and I'll be quiet after that, but I just wonder, what would be the ideal makeup of an additional sample?
I think primarily what we're going to look at is we're always going to look at the training profile of the crew and their radiation profile. And those two things, with one-year crew members, if you're naming them to a mission that's coming pretty soon, and this happened when we chose Scott, you have to make sure they have enough training, that they don't need all the extra training so they can actually slot into the flow, the mission flow. So it's going to be those kinds of practical things that determine which crew members would be selected should we get an agreement to go forward with future one-year missions.
Probably wouldn't want to send somebody who has not flown in space before.
Right.
I would think that that would likely be a consideration.
Yeah. In the back here.
Hi, I'm Natalie Keith with Fox 26 News. And I'm wondering if there were any really big surprises from this trip, or what do you think the biggest thing is that you learned from this trip?
So
Biggest thing I've learned is a year is a long time. You know, and every time I would say to my brother, hey, this is going by really quickly, he would say, no, it's not.
I would say one thing that was honestly surprising to me is the focus that everybody had on this particular crew member and this particular mission. It's kind of funny how we can be doing the same important research all the way through, and we're making discoveries all the way along, but boy, if you get a first, then everybody pays more attention. So that was a surprise to me, just as a scientist, to see that it takes one of these firsts to get folks to pay attention to, but at the same time, we're improving people's lives on Earth, improving people's health, and it's harder to get that kind of out there in the news.
How long will it take you to learn the effects that this trip had on his body? I mean, how much longer will you study him and really know what that trip did to his body?
We have plans for data collection on both Scott and Mark up to 9 months after this landing, and that's just data collection, not even including the analysis time. Obviously, you can't analyze data that's collected 9 months from now until after you've collected it. And I already mentioned the data coming, or the samples coming down via SpaceX in May. But just because the flight's over doesn't mean the mission's over, and we've got lots of other investigations, lots of other little surprises to spring on Scott and Mark as we continue on in this process of collecting the data on them. And then NASA likes to give the investigators a good solid year to analyze their data and then to write it up for publication, so it can go into the publication, into the scientific literature, and be peer reviewed by people that know as much about the data and what it should like as the investigators, to see whether it really does hold together. So this time next year, I'm hopeful we'll start seeing the initial results come out from the investigations that were fairly quickly completed and fairly quickly analyzed. And then I look for a constant stream of insights and results from this mission for at least another year after that.
But every astronaut that flies essentially is part of a broader experiment. So astronauts that have left the agency come back year after year. They participate in something we call the long-term study of astronaut health, because not every effect is going to happen right away. There's been interesting work done in the past on things like cataract incidence, other kinds of long-term cancer risks. Those things happen over very long-term studies. So the research investigation, in some senses, never ends.
Gina?
Gina Sinceri, ABC News for Mark. What were you and the rest of your family able to do to help Scott through this year psychologically, and what kind of family support were you able to provide him?
When he's on Earth, I'd often, he might call me, I might be in the middle of something, and I might go straight to voicemail. When he's in space, I don't do that. I'll always take his call, so obviously sometimes I would just miss them, but by accident, but not intentionally. So I'd always try to have my ringer on, be available there, to talk to him when he wants to talk. You can't call up to the space station. You can only call down. So there's no really calling somebody back when you miss the call. So I think, it might seem like a small thing, but I think to him, and also, having that experience myself at a much reduced period of time, I think that's really important. So just to try to keep that communication with people on Earth and that connection is something that's really critical for a long-duration crew member.
Kevin Reese with KHOU here in Houston. While we're waiting on the science, Mr. Kelly, anecdotally, between you and your brother, you've met, you've talked, all of these things. Are there things that you have noticed about each other, other than he's probably taller than you now? Are there other things that would not taint the science that you could share that you guys are already noticing?
Well, I saw him last night when he got off the airplane. We had dinner last night, but he was pretty tired. It's, there's the jet lag from space is pretty serious. So, so he was kind of tired. So we haven't talked a lot about it. There's some things that he pointed out, but I'll let him share that with all of you, and how he feels. He did say he feels different now than he did after spending 6 months in space. So.
And by different, he'll talk about that, but you can't
I think he will.
On different? Yeah.
What's that?
You can't elaborate on different?
I could, but I think that should be for him to talk about, because that's his personal health situation and how he feels.
Okay.
Manuel Borges with CBS News. He probably now holds the record for social media presence while in space too. He was tweeting and Instagramming so much. How important was that for this mission? And what was it like to be able to just at least get a daily update of what he's doing up there?
I think it's important for NASA. I mean, NASA relies on congressional support, which means that you have to have strong public support, and any opportunity to engage with the public on a positive, in a positive way, I think is really important to the agency. The agency needs to, tell the story of human spaceflight and science in general. So so he took that very seriously. I mean, that he was going to try to engage with the public on a very regular basis. I think he went over 1 million Twitter followers yesterday. In my opinion, it is the public outreach and engagement and sharing the story is a really important aspect of these missions.
Was it also reassuring to see him smiling and goofing off and having a good time up there?
Yeah, I think that's people like that. I mean, NASA can be obviously a very technical, very sterile. The space station could be very sterile environment and very technical. And some people just aren't technical. Some people, connect to things in a different way. So sure, I mean, seeing somebody who's living in space for a year, having a good time and enjoying it is a way he can connect with certain people.
In the back there.
Jake Reiner with KPRC Channel 2 in Houston. I know you guys can't talk about the twin study in terms of the data that you guys collected, but what are some things that you guys were looking for before doing the twin study? What are some things you wanted to find out and would help you in the research mission?
Well, the purpose of the twin study was really to understand what can be learned from doing a new class of investigations, a new class of work literally at the genetic level that NASA is not doing a lot of, at least in terms of the astronauts, at least not in a widespread sense. And so we're really trying to understand what the advantages are of doing this kind of work, and what better way to do it than to compare two individuals who, at least at birth, were fairly identical genetically. So by looking at Mark's results collected over the course of the year, we can see what the normal variations might be, and then by looking at Scott's collected over the course of the year, we can see where his variations are greater than Mark's have been. And those will tell us what areas to investigate in the future, not on twins, because there's no more twins in the pipeline, but on astronauts in general, using this new set of what I call 21st century medical techniques and technologies to supplement the ongoing research we're already doing. In fact, of the 10 investigations, 5 were already planned for Scott for his one-year mission. They were simply reapplied to the twins study as well. But 5 are brand new investigations from brand new investigators who had never thought they had anything in common with spaceflight and spaceflight research, which essentially opens up an entire new community of research and researchers to help us solve the problems that we have to address so we can send astronauts safely to Mars. So that's a very exciting benefit right there, is just access to a new set of eyes, a new set of brains that can think about this kind of stuff. And also they've enjoyed immensely being part of the space show, because it's a lot of fun. They enjoy seeing, coming and interacting with Mark when they do their data collections during the course of the year. They enjoy seeing Scott in flight and knowing that they have a role to play in that. So there's a lot of these interconnections that Mark was just talking about making sure that everybody feels part of the program, as well as some very, very tangible benefits, I think, in the outcome of these studies.
But it can't be understated, I think, what Mark and Scott gave to science by coming to NASA and saying, why don't you take advantage of the fact that we're twins? Because the reason that we hadn't really gone down this genetic route is because of all the medical privacy concerns and issues with Genetic Information Non-Disclosure Act and other things that made it really challenging for NASA to come to them to ask for something like that. So because they came to us, we were able to work out a policy and an approach and really open up this area, which you'll hear this mentioned by your doctor too. It's called personalized medicine, looking at your genes and understanding how they're going to react to whatever experience or whatever medical problem you have. So this is really an important advance for NASA that they made possible by coming to us with that offer.
Thanks, Mark. Eric?
Eric Berger with Ars Technica. I have a question maybe for John. If you can't talk quantitatively, maybe you can talk qualitatively about how Scott did in his initial performance tests in the medical tent in Kazakhstan, either sort of generally or compared to the last 6-month mission he did.
Well, what I've been told is that he completed all the testing, which is in itself a real accomplishment, because it's a lot of work to do immediately after a very strenuous and I think harrowing episode, when you land in the Soyuz. So he has continued to perform at very significant levels. He's been there for all the studies. He's been a full participant and seems to be doing it by taking it in stride. He said when I see him on TV, he seems to be looking like he's just fine doing it all, and doesn't seem to slow him down.
Do you get a sense that he could have put a spacesuit on and walked out onto the surface of Mars?
I get a sense that he could have. That's my strictly qualitative, non-professional assessment, having never interacted with the spacesuits myself. But he sure, if he couldn't, I can't imagine somebody that could have.
Robert Perlman with collectspace.com and space.com. Working off the earlier question that there are no more twins in the pipeline, NASA is in a recruitment right now of astronauts. Is there a scientific basis or desire to see more twins as a control sample and space sample recruited for the program as a specific goal?
I don't think I will make that request of the selection committee to look for twins, but I think if twins do show up, we'll certainly be interested in their success as astronauts and be thinking of ways subtly to suggest to them perhaps that they might like to be subjects in our studies.
Kevin Quinn here from KTRK in Houston. Can you talk bigger picture, down the road, human spaceflight, long duration spaceflight, top 3 things you're concerned about, how this specifically will address those top 3 things? Well,
from the perspective of the Human Research Program, the top things we're worried about are are the psychological, psychosocial aspects of spaceflight, being confined in a small vehicle. If you're on your way to Mars, you're remote from Earth by minutes to tens of minutes by radio, same faces all the time, small environment, things like that. So there's, in the different circadian rhythm impacts, or sleep, wake cycles. We have concerns about continuous or autonomous medical care. How do you take care of astronauts who are off of the Earth and too far away even for a radio or a telephone house call? Clearly they have to have all of the skills and all of the wherewithal on board and know where to find it if they need it. We're concerned about space radiation, and a lot of that space radiation work is being done on the Earth because the space station itself is orbiting within below Earth's magnetic field and is not exposed to the deep space radiation that astronauts will experience on trips to Mars just hours after leaving Earth, and then continuously for the remainder of the, say, 2.5-year round trip. We're concerned about those factors, but we're also concerned about everything else that's required. How do you provide the right kind of food? And I don't just mean MREs or frozen dinners, but the food that maintains its freshness and its nutrition for long periods of time, stored in less than perfect conditions, and remains appealing and palatable so the astronauts don't lose interest in eating. And I personally cannot imagine losing interest in eating, but I think some people have experienced that. We're interested in things like Mark described Scott's report of visual changes that occur in spaceflight. This is a fairly recent finding amongst space station crew members. And in retrospect, we sort of knew it was coming, but we didn't realize the significance of it, and we haven't, as far as I know, seen it plateau really. So maybe the one-year mission will tell us a little bit about whether the visual acuity changes are the same after 1 year as they were after 6 months. But essentially, every kind of body system that you can imagine is influenced by the factors of spaceflight, including especially weightlessness. We're worried about things like bone integrity, bone loss, not just calcium loss, but where the calcium came from and how the bone that's left behind is able to withstand the stresses that will be imposed on it, not just on a mission to Mars, but in the remainder of the astronaut's life back on the Earth. Muscle function, cardiovascular function, you name it, we're interested in all of it, and missions like this help us to answer the questions that we have in front of us. So at the end of the space station era or thereafter, we can give a go to the program manager of the Mars program and say that, yes, we think we understand what needs to be done to keep astronauts healthy, happy, and performing at a high level, not just alive, but performing at a high level for the duration of the Mars missions.
Okay, we're going to go to our phone bridge now to take a few questions. And just a reminder, if you have a question, you need to press *1 to get into the queue. Let's go ahead and start off with Marcia Dunn in the Associated Press.
Yes, hi. My question's for you, Mark. I'm just wondering what your impressions were when you were finally reunited with your brother, and even now, any surprises about him physically, mentally, behaviorally, any worries seeing him jump to his pool and whatever else he might be up to?
Adjust to his what?
Jumped in his pool.
Oh, he jumped in his pool. Yeah, I wasn't there for that. It was a very late night. I think that was about 4 in the morning. Any concerns? No. I mean, he's a professional. He's done this before. He's even done, as you know, a long duration mission for 6 months. I think he will tell you that this is different. He feels different, and 1 year is a really long period of time. But I haven't noticed anything, specifically that makes me think that it's going to be, a long time for him to, get back to normal physically or recover from this. So I think a lot of people saw him get out of the Soyuz and how good he looked, and I imagine if Roscosmos, if the medical folks around him and the NASA folks that were there would have allowed him, he would have loved to have been able to walk from the Soyuz. But that's not permitted. But I think he'd be, a good example of somebody who could probably, make that trip to Mars, for 6 months and then, in a short period of time, do some reasonable work.
All right, next we will go to Irene Kloss with Reuters.
Thanks, Dan. I have 2 questions. The first for Dr. Charles. Just from a radiation exposure perspective, is Scott Kelly now at or beyond his lifetime exposure, from a NASA government employee perspective. And for Mark, aside from that really fun-sounding MRI, can you talk a little bit about some of the other protocols and things that you've done this past year? You've matched your brother's exercise regime, for example, and also if you have participated in the cognitive tests and things like that. Thank you.
In terms of the radiation, I don't know those numbers, and sadly, if I knew them, I couldn't tell you because that's protected by medical privacy. But I guess we can infer that he had enough radiation tolerance left at the beginning of the one-year mission, and he certainly picked up radiation during the one-year mission, but I cannot tell you how close he came to his lifetime limit.
Knowing how close other people have come to the limit, I would imagine that he's probably getting pretty close. After spending over 500 days in space now, I mean, he's got to be up there by the upper limit, would be my guess. The other things that I've been doing, personally, during this year is, I come here, I do ultrasounds on certain body parts, my eye, my carotid artery, brachial artery, heart, part of my arterial system in my lower leg. I'm not sure exactly what they're looking for there. So there's, there's that. There's giving 30 tubes of blood, and I don't keep track of what each tube of blood is for or where it's going. There are urine samples, saliva samples, and other things that, go off to researchers. The MRIs, I did an MRI yesterday. I have another one tomorrow. There's a test where they reduce the pressure around your lower extremities to look at the function of your circulatory system. And I suppose, I could have gone and figured out exactly what each of these tests, which research it is for. But in, my opinion, what I'm really interested in is the results. And, where that tube of blood goes to or what that MRI is used for, I think I'll let the researchers deal with that. You asked about the cognitive testing. And during my brother's mission, he was doing these cognitive tests. It's on a NASA laptop. There's about 10 different tests. And I was doing them around the same time that he was. I think he probably did one last night, and I did one last night as well. And it takes about 30 minutes. It's pretty interesting. Over a period of time, I've noticed that just with time, because you're doing the same test over and over again, you are getting a little bit better at some of these things. It's been overall a really positive experience for me. As an astronaut, having flown 4 missions, while I was at NASA, I would have to say, as far as human research goes on me, this is probably by far the most, collectively that I've done.
All right, next we'll go to Brian Resnick with Vox.
Hey, thanks for taking my question. It's for probably either John or Julie. I'm wondering, is there an upper limit to the amount of time a person can stay in space? Like, could you potentially do a 2-year mission, a 3-year mission? And in those cases, what do you suspect would be the limiting factor that would determine you can't stay in space after a certain amount of time?
Well, the goal isn't just to set a record. The goal here is to really be applied to the practical things that we need humans to be in space for that period of time. And so that's the one-year mission helps us model basically a transit to Mars and a return. And so that's why we're focused on extending out beyond 6 months to make sure that we've got all of those risks understood and covered. There's no inherent limit if we have the right countermeasures in place. As long as the crew member's doing enough exercise, we're getting a much better idea, say, of how to protect their bone, how to protect their heart with exercise and diet and so forth. But it's hard to see what other than but you have other cumulative risks that come together, like radiation and so forth. So I don't think we would really push or extend. We certainly wouldn't want crew members going beyond their occupational radiation safety limits. And there's really not a reason to just push it just to set a record.
Okay. Next, we'll go to Ann Ball, Voice of America, Washington. Okay, she might have dropped off. Let's go to Tom Rizin, U.S. News and World Report.
Yes, thank you. This is for Mark and the scientists. Could you talk a little bit about what you expect the twin study could teach us about cancer? Because Scott was up in the space station outside the protection of Earth's atmosphere, and I know that there's a various amounts of medical treatment. You expect to learn a lot about the human body, but what do you think we can learn about cancer from him being exposed to radiation for so long? And you're taking a very closer look at that than ever, and after astronauts have gotten back from space.
Well, I think John would be better as a scientist in answering this question, but certainly there is, I mean, I think we all know there's a connection between radiation and cancer, but I'll leave it up to him to explain that further.
I was kind of hoping you'd answer that one. Clearly, the cancer is induced by changes, the mutations that occur at the genetic level, and I think we're going to be learning things about the changes that occur in both these gentlemen's genes from this investigation. And some of those things may well be the rate of mutations that occur in those genes, especially in Scott in the flight environment with all of the various stressors that he was confronting. I would be foolish, I think, to try and predict how that's going to change how we understand cancer, but I am confident in saying that it will influence how we understand cancer, and I'm looking forward to seeing the results myself after the investigators have analyzed the data so they can perhaps answer that question for both of us.
Okay, we got two more on the phone. Let's go to Michelle Fitzsimmons, Tech Radar.
Yes, hi. My question is for John and Julie. You had mentioned, I think, Julie, earlier, some of the technology experiments. So are there any preliminary findings on the technology front as far as the tech that was used and what will be needed in future long-term space missions?
There definitely are. Just to pull a couple off the top of my head, of course, we did 3D printing on ISS and looked at assembling some simple tools and parts together. It was a successful demonstration of a new approach, but I would say that we will be looking and actually dissecting and taking apart some of those parts to see whether there are certain flaws in their construction that might make them weaker than we expected. But we also found that we're not fully satisfied with the technology as it exists today. We need to look at other materials, maybe even improving some of those processes. So it's a stepwise process of improving technologies as we go. So that's just one example that came to mind.
Okay, let's do Colleen McCarthy, Optometry Times.
Hi, my next question is for Julie and John. I was wondering if you might be able to discuss how the use of the lower body negative pressure suit differed on this mission and whether or not you believe that had any positive impact on Scott's vision.
Let me do that one. I'll do that one.
You got that.
The lower body negative pressure suit is a Russian device. It's used by the Russians specifically in preparation for the end of the mission. They go through a protocol of decompressions and of oral fluid loading, fluid and salt tablet ingestion for several tens of minutes at a time, several times a week for the last month in flight. The American astronauts are not required to do that. It's a decision by the American space medicine community that the benefit is not something that they're worried about because astronauts are landing recumbent in the Soyuz and there's a lot of support immediately after landing. But it is a traditional part of the Russian program. The last time that anybody has done LBNP, lower body negative pressure, for research purposes was just about 20 years ago on the Neuralab Space Lab mission. And then before that, there were several investigations using lower body negative pressure as a potential countermeasure on several shuttle missions. So the difference is that this was one of the first times in recent memory that LBNP has been done for research purposes. We had to get clearance from the Russian medical community because using this piece of end-of-mission medical hardware for research purposes necessarily reduces its lifetime, its continued usefulness, the number of times you can decompress in it for future end-of-mission preparations. But they agreed with us that the investigation was interesting enough and potentially significant enough that it was worth the expenditure of a limited number of runs in the Chibis device, and that's CHIBIS. It's Russian for a kind of a sparrow. But it was used specifically to reverse the fluid shifting that occurs in all astronauts in spaceflight. The interest is to understand how that fluid shifting, and it goes from the lower body into the upper part of the body in weightlessness and sort of stays there until you come back to the Earth after spaceflight and gravity relocates some of the fluids back in the lower part of the body. It was intended to understand how the fluid shifting that occurs may influence the changes that occur in the ocular system, especially in the shape of the globe of the eye, as well as the pressure inside of the head, the intracranial pressure and the distribution of fluids throughout the body. The hypothesis, several hypotheses, but one of the hypotheses was that shifting of the fluid out of the upper part of the body might have an effect on the shape of the eyeball. If Scott or Mikhail's eyes had become a little bit flattened because of their time in spaceflight, and if fluid shifting is involved in that, then perhaps transiently removing some of that fluid would have caused some sort of rebound in the shape of the eye. And as I said, I have not yet seen the results from this investigation, so I'm looking forward to seeing that as well. I do not think that the brief interventions that they both experienced over the course of 340 days, and it was 1 hour on two continuous days, 3 times in flight, so a total of 6 hours per person. I really don't think that's going to reverse the fluid shift that has occurred over 340 days in spaceflight. So I'm thinking of it more as an intervention, an acute, brief, transient intervention to answer a specific question relating to intracranial pressure and shape of the eye. But the results that come back from that should be very illuminating and enlightening in that regard.
Okay, we'll bring it back here in the room for follow-ups in just a moment. I wanted to take some social media questions real quick. I know we have a couple.
So this question is for John and Julie, and it's coming to us from Liz Collins on behalf of her 5th grade class. She's wondering, what experiment do you think was most beneficial for the year in space?
Most beneficial? I would have to say that there were a number of studies that were going on looking at cell division and cell types. And I think if you look at the core of medical care going on right now and understanding how cells divide and how cells become differentiated, which means become the kind of cells in our bodies that do different things, we really don't understand that very well, and that's the core of research on how we could prevent aging, how we can solve all kinds of medical problems. And the fact that you see those different patterns in space, I actually think that's some of the most important work that happened.
So we have another one, most likely for John. Jason Sexton is wondering, did he really grow 2 inches while in space this past year?
I don't know if anybody knows that. I'm not sure when that measurement was made, but as much as he did grow in height, it probably went away very quickly because it's a function of essentially fluid accumulation in the discs between the bones in our spinal column and our back. So as we all sit here on the ground or stand here on the ground, our backs are being compressed. You can often feel that, especially at the end of a long day. You know your back is tight and sore. And part of that is signaling the fact that the discs that cushion between each of the vertebral bones in your back get compressed by the weight of the body above them. Now, in the absence of gravity, they have a certain natural resilience and they bounce back, they spring up, and they absorb body fluids, so they stay hydrated. So during the period of time that astronauts are in space, they do get a little bit taller, tall enough to make a difference in spacesuit fit and also to make a difference in the seats that the cosmonauts and the astronauts sit in the Soyuz vehicle. They have to be specially designed to accommodate a slight increase in height. But unfortunately, that height difference goes away as soon as they come back to the ground and stand up for the first time. The gravity affects those intervertebral discs and squishes the fluid out of them. And before too long, astronauts are the same height they were before.
He's been squished back to normal height.
Let's do one more from social.
This one is most likely for Julie. Commander Aristotle on Twitter is wondering, is there any possibilities that other veggies will be grown on the space station?
Yeah, so Veggies is an interesting study because what we're doing with that is we're really testing our ability to take a small greenhouse with us to Mars. It's very small space and low power, low energy and so forth. And on the way to Mars, there are a couple reasons we'd like to have a greenhouse. One is for the psychological benefits of having some living organisms to go along with you, but another is to be able to grow fresh food for some of the vitamins and especially antioxidants that break down in space. So it'd be nice to have some things like maybe spinach or some fresh berries, sources of vitamin C. And so we, as you know, while Scott was up, we grew a red romaine lettuce, which is a very nutritional form of romaine lettuce, and we also had the zinnias. Personally, I'd like to see a fruit come up in the future. Our Russian colleagues in their larger, heavier greenhouse have grown things like peas and other plants. So we have some work to go still, but it was a big advantage just to get to the point where we were comfortable that the food was safe to eat that had been grown in space, and that was an important accomplishment this mission.
Okay, we'll take a couple of follow-ups here in the room, all the way in the end here.
Hi, Alexandra Becker with Texas Medical Center News. Could you speak a little bit more about how data from the twin study and maybe the research process itself might benefit human health here on Earth in the future?
That's always a difficult kind of question to answer because it requires a sort of a direct mapping of the results from spaceflight to life here on Earth. But I don't think it's an exaggeration to say that everything we learn about the human body, whether it's in space or on the ground, benefits all of us here on the Earth. There's guys like Mark and Scott, while very fit and unique, they have the same basic physiology, the same basic anatomy as the rest of us do. And by allowing us to make the measurements on them in an in-depth and detailed manner repeatedly in the most novel circumstance that I can envision, which is weightlessness, that tells us things about how all of our bodies respond to stresses and eliminates some of the noise, some of the variability, some of the uncertainty, because they are, in this case, they're twins, and so we have some very clear comparisons between one person in space and one on the ground, but also because they're very healthy, so that eliminates a lot of the complications of not quite so healthy bodies. But very brief, it's too late to be brief, but very briefly, anything we learn about people any place is going to benefit life on Earth.
Well, and we've already had examples where the research in space led to follow-on research by, say, pharmaceutical companies and others. There's already a drug on the market that was tested on the space station, basically to evaluate its mechanism of function. Merck, Eli Lilly, other companies are using ISS to take it that second step. So the basic information, it takes another couple sets of research to get it to a health benefit. But if you look at all the effects overall on crew member health, the bone loss, cardiac deconditioning, they all start looking a lot like aging, and those are the medical things that we care about most back here on Earth.
Mark.
Thank you, Mark, for aviation and space technology. You mentioned that there's still some medical specimens. I guess there's specimens of various types on the space station. Can you describe sort of, I guess it's blood, but what it is, and is there a certain period of the time that it's been in space that those samples cover that's critical to the overall project?
It's primarily the most recent blood specimens that were collected on Scott. The earlier specimens came back on earlier down mass vehicles like SpaceX's before.
But yeah, we have a big freezers on ISS called Melfi, the minus 80-degree laboratory freezers for ISS. And then we have small freezers on our SpaceX return vehicles that bring those samples home. We want to keep them frozen the whole time. We also have some cold bags we can bring home on a SpaceX to have extra capacity. And we try to get a block of samples together from a single experiment and bring them home all at once. So the next SpaceX is going to be a really important one for having a lot of these samples.
Eric.
Eric Berger again with a question for John. So obviously Mark and Scott are talented, intelligent guys. I want to know about the psychology of this. So being up in space away from loved ones for a year, now you get to call them at any time, but it's hard, it's isolating. What percentage of the general population do you think has the psychological makeup to handle this kind of a situation where you're staying on task every day and in a difficult situation?
I would be scared to guess what fraction of the general population can do that. I suspect it's more than 1 in 1,000 because And I say 1 in 1,000 because that's the number of people we're going to select in the next astronaut selection out of the ones that applied. But I think we can all probably answer that question for ourselves. Just imagine who amongst all of your acquaintances could maintain that kind of focus on task in a fairly confined environment with the same faces to look at all the time and under, no kidding, life and death stresses the entire time. Who among us could do that? I'm not sure I would be really one of the chosen ones in that regard.
All right, well, that's going to be all the time we have for this press conference today. You can, of course, continue to follow the mission on nasa.gov/1year. I want to thank all of my guests here today for their time and for all of their work to make this mission the success that it was. Dr. Julie Robinson, Dr. John Charles, and Mark Kelly, of course. So we're going to break away for now. Stick around, though, because coming up next is the Year in Space man himself, Scott Kelly.